We will now determine if the lines L1 and L2 are parallel, intersect, or skew. So first, we will determine if the lines L1 and L2 are parallel. So we consider the lines L1 and L2. To determine the lines L1 and L2 are parallel, we set up the equation for the ratio of the direction numbers. So we obtain the direction numbers just by taking the coefficients of the variables, that is the parameter. For L1 T is the parameter and for L2 S is the parameter. So I'm going to set up this equation. So in x, the coefficient of t is 1. So I take this quotient as 1, and then this has to be divided by the coefficient of s in x, which is negative 2 here. And this has to be equal to, we now take the coefficient of t in y for L1, that is 2, and then this has to be divided by the coefficient of s in y for L2, that is negative 4. And we set up this equal to, now we take the coefficient of t in z for L1, that is negative 1, and this has to be divided by the coefficient of s in z for L2, which is 2. Now let's check this equation is true. Let's simplify this. 1 over negative 2, we can write down this as negative of 1 half, and this equals 2 over negative 4. This gets reduced to negative 1 half, and we already have negative 1 half. So this is equation, that is, this equation is true. And since this satisfies this equation, we say that the lines L1 and L2 are parallel. L1 and L2 are parallel. Now that we determined that the lines L1 and L2 are parallel, we'll find the distance between the two lines. So I'm going to write down the formula to find the distance between the two lines. So we see that distance between the lines, and this equals PQ vector cross V1 vector. We have to find this absolute value, that is the magnitude of the cross product of PQ and V1 vector divided by the magnitude or the length of the V1 vector. Let me explain how we get this PQ vector and V1 vector. So PQ vector is basically a vector starting from the point P and ends at Q. That is a point on the L1, line L1 we consider as point P, and a point on the line L2 we consider as point Q. So when we connect these 2 points, we get this PQ vector. Let me show this diagrammatically. Since we determined that lines L1 and L2 are parallel, we see that this is line L1 and this is line L2, and we consider a point on the line L1 that we consider as P, and then we consider another point L2 on the line L2, that is the point is Q, and then we connect these 2 points by a line or a vector. So this is our PQ vector. And we also consider a vector, that is a vector V1. This is in the direction of line L1, and we have to take its cross product, find its magnitude, and divide by the magnitude of the V1 vector. So first we will find a point on the line L1. Let's see how to find the point on the line L1. So first we have to find a point. So on the line L1, let's consider this line L1. So when we look at the parametric equation, the first value without the t parameter corresponds to a point, that is 2, negative 1, and then negative 1. This is a point on the line L1. Maybe even if we set up the parametric equations at t equal to 0, we get the same point. And now let's see how to get the point Q on the line L2. So this is a point on line 1, and this is a point on L2. So once again, we have to take the take the numbers without the parameters. So we have to take this -1, -5, and 2. We consider that as a point, that is -1, comma -5 and 2. So this is a point on line L2. Consider this as Q. Even if we set up the equation, that is here for line L2, it is S. So even if we set up S equal to 0 into the line 2 equation, we get the same point. So now that we have obtained the 2 points P and Q, let's find a vector PQ. So we know how to find a vector given 2 points. We have to subtract the coordinate of the second point. That is, we consider the second point, x coordinate is -1, and then subtract the x coordinate of the first point, that is the P point, which is -2. Since this is a vector, we have to write down in vector component form. So we have to use this bracket, comma. We put the y coordinate of point Q, which is -5, negative of -1, and then we put the z coordinate of point Q, which is 2, minus the z coordinate of P is -1. So let's simplify this. Therefore, we see that the PQ vector, and this equals -1, -2 is -3, and this becomes -5 plus 1. This is plus 1, -5 plus 1 is -4, and this becomes 2 plus 1, which is 3. So we have obtained the PQ vector, which is -3, -4, and +3. Now we will determine the direction vector v1 from line 1. Remember that the direction numbers are given by the coefficients of the parameters. That is, the coefficient of t is 1 for x, and coefficient of t for y is 2. And similarly, the coefficient of t for z is -1. So we can utilize that as a direction vector. So I'm going to write down this v1 vector equals, it is 1, 2, -1. This is 1, 2, and -1. Now we determine the cross product of these two vectors, that is PQ time PQ vector cross with V1 vectors. Because according to the formula, we have to find the cross product of these two vectors and find its magnitude. So let's determine the cross product of these two vectors. So I write down PQ vector cross V1 vector. I'm going to use the determinant form. So I put this I hat, j hat, and k hat. These are the unit vectors along the coordinate axis. And now write down the PQ vector, that is -3, -4, and +3. And in the third row, I write down the V1 vector, that is 1, 2, -1. And we have to evaluate this determinant. Let's evaluate this. So this equals, first I put this I hat times of, I have to leave the row and column representing this I hat. So when I leave it, I have to leave this column as plus I have to leave this row. And then I have to evaluate the 2 by 2 determinant. So this is the 2 by 2 determinant we are going to get. So let's evaluate this. This is, we have to take the diagonal and subtract the cross diagonal. That is -4, -1, product is +4, minus the product of the cross diagonal, that is 2 times 3 is 6. And now I put negative j hat, and I have to leave the row and the column representing the j hat. So I have to leave this row as plus leave this column. And when I do that, I should evaluate this 2 by 2 determinant representing this column as plus this column. So it's basically, we have to product this diagonal, that is this -3 with -1. So -3 times -1 is +3 minus, and then we have to product the cross diagonal, that is 1 with 3. 1 times 3 is 3. And then I put this k cap, is this k hat, multiply with, I have to leave the row and the column representing the k hat. So I have to leave this row as well as this column. And when I do that, I get this 2 by 2 determinant. I have to evaluate this 2 by 2 determinant by taking the product of the diagonal. Negative 3 times 2 is negative 6. I put a minus, and then 1 times negative 4 is negative 4. So I put negative 4. Now let's simplify this. So this gives 4 minus 6 is negative 2. So I can put this as negative 2 I hat. And 3 minus 3 is 0. So 0 times g hat is the 0 g hat. So you can just ignore that. Maybe we can also put it as 0 times g hat plus this is negative 6 and positive 4. And this is negative 2. So it is negative 2k hat. Let's write down this in component form. So this equals negative 2, comma 0, comma negative 2. Therefore, the cross product of these two vectors, that is PQ vector cross with V1 vector, and this equals in component form negative 2, 0, negative 2. Now let's find its magnitude. So we have to find its magnitude of PQ cross V1 vector. We find it by taking the square root of the sum of the squares of the components, that is negative 2 square plus 0 square plus negative 2 square, and this equals negative 2 square is 4, 0 square is 0, so you can just ignore that, plus negative 2 square is once again 4, so we get square root of 8. So this is the magnitude of the cross product of the vectors PQ cross V1 vector. Now let's find the magnitude of the V1 vector. So for that I need to copy the V1 vector. Okay. So the V1 vector is nothing but the direction numbers of the line 1. So here we consider the coefficients of the t from x, y and z. So it is 1, comma 2, comma and negative 1. So we can consider this as a V1 vector. In fact, we have already found it here, 1 comma 2 comma negative 1. So let's find its magnitude. V1 vector is 1 comma 2 comma negative 1. So when we find its magnitude, we have to take the square root and find the sum of the squares of the component, that is 1 square plus 2 square plus negative 1 square. And this gives 1 square is 1, 2 square is 4, and negative 1 square is 1. So it is 1 plus 4 is 5, 5 plus 1 is 6. So we get root 6. So now that we have determined these two magnitudes, we can find the distance using the formula. So we see that the distance between the two lines, this is distance between L1 and L2. And this equals the magnitude of the cross product of the vectors PQ cross V1 divided by the magnitude of V1 vector. So let's substitute these values which we have found. PQ cross V1, its magnitude is root 8. So I put root 8 in the numerator, divided by the denominator is root 6. So we now rationalize this, that is we can multiply and divide by the radical in the denominator, and this gives square root of 48, and this gives root 6 times root 6 is 6. We now write down this square root of 48. You can write down that as 12 times of 4 divided by 6, and in fact we can write down this as 4 times of 3, and then we have 4 divided by 6. So since we have a pair for 4 inside the square root, we can just simply take it out of the radical. So it becomes 4 root 3 divided by 6. This equals, we can simplify this 4, 6, which is 2 times 2 is 4 and 3 times 2 is 6. So it is basically 2/3 of multiplied with the radical 3. So this is the distance between the two lines L1 and L2. And in fact, if we have to give this in decimal, this is approximately 1.0 1547. So we found the distance between the two lines L1 and L2. In terms of exact value, it is 2/3 root 3, or in terms of decimals, it is 1.1547. So the correct answer to this question is answer choice A, where it says the lines L1 and L2 are parallel and their distance is given by these two quantities.